Hey, welcome back. So let's just start off with giving a general formula for a quadratic. So that will be f of x will be equals to ax squared plus bx plus c, yeah? And there are two ways that you can solve for any kind of quadratic. The first one would be the discriminant, and the next one would be the complete the square. So to give a revision of what is a discriminant, here's the formula. So x, so x1 or x2 is equals to negative b plus or minus the square root of b squared minus 4ac over 2a. Now, this term inside the square root, that's called the delta, which is represented by a triangle. So if delta is greater than 0, we would have a unique solution or a unique root. If we have a delta that's equals to 0, then we will have a repeated root. And then finally, if we have a delta that's less than 0, which means that b squared minus 4ac is negative, then we would have a complex root. So let me give you an example of how this looks like on the x and y plane. So let me draw a x and y plane. So this is my x-axis, so this is my x, and this will be my f of x. So let's start off with, okay, first of all, let's label this. So this would be 1, this will be 2, this will be 3. Okay, so for the first one, a unique root is where a parabola intersects on the x-axis, okay, where you have two intersection points. So for example, it could look something like this, and you could have it like that. Okay, so that's number one. Or you could have a repeated root, which means that the vertex, this is the vertex, the tip of the parabola only touches one point on the x-axis. So it could look something like this. Okay, so this would be number 2, not 12, 2. And finally, the complex root is when the parabola hovers above the x-axis, so it never touches the x-axis. So it should look something like that. Okay, that's 3. Now we can never express complex root on the Cartesian coordinate system. So a Cartesian coordinate system is where is what you use to draw on the x and y plane, but for complex roots we can only express it in the Argand diagram. Okay, so we'll get to that in section 3, where we actually go in depth on complex numbers. Okay, so let's move on. Now let's look at the complete the square method. Okay guys, so let's look at complete the square. Suppose that you have f of x is equals to, let's say, x squared plus 6x plus 8. Yeah, now for any quadratic, right, that we can always make this two terms, x squared and 6x, into what they call a perfect square. So for example, a perfect square would be let's say x plus 3 square, or it could be x plus 5 square, or whatever. So these are perfect squares, okay, where you don't have a constant sticking out. For example, if you have x plus 3 square plus 1 or something, then it wouldn't be a perfect square. So how do we make this into a perfect square? Well, what we need to do is that we need to drop away the x in this term, and then drop away the power and equate this to 1. And then we're gonna half this number by 2. Okay, so it will look something like this. So x plus 3, and then the whole thing square, plus 8. Now, if I do this, then I'll introduce a new term, right? So if I expand this bracket, if I expand this bracket, x plus 3 square, that will become x square plus 6x plus 9. Yeah. Now this term here is okay. This term here matches exactly with this, but not this term here. So that means that we need to actually minus the 9 off. Okay, because while we do this, yeah, we are introducing a positive 9, so we have to minus that 9 off to give us back this term here. So what would this be? That would be x plus 3 square minus 1 gives me 0. So if we solve this, that will be x1 equals to negative 2, and then x2 would be negative 4. Okay, now let's look at another example. Okay, so let's look at this simple equation. Again, we're gonna solve this by using complete the square. So again, we're gonna drop the x, we're gonna drop the 2, and then we're gonna square the whole thing, and then half this number. So that will look something like this. So x plus 3 over 2 square plus 2 minus the square of this number. Yeah, because by doing this, I'm generating a positive 9 over 4. So I have to minus this off. So it's minus 9 over 4 gives me 0. Okay, so that would equals to 8 over 4 minus 9 over 4 equals to 0. So that means that x plus 3 over 2 square equals 1 over 4. So that will be x plus 3 over 2 equals to plus or minus 1 over 2. So that will be x1 equals to negative 2, or x2 equals to negative 1. Okay, again, completing the square is an important skill that you should learn and you must understand. There will be more questions on lecture 8 where I go step by step on how to solve the questions, and also if you have any questions regarding completing the square, you can always drop me a question on the discussion board and I'll get back to you as soon as possible. So yep, keep practicing guys, and I'll see you guys in the next lecture.